Okay, hello everyone. So kind of don't want to do dynamic programming anymore because, um, realistically speaking, I guess being asked that might not be as like relevant. So what we're going to do is do topological sort instead. And so from Wikipedia itself, wow, Wikipedia. In computer science, a topological sort or topological ordering of a directed graph is a linear ordering of its vertices such that for every directed edge uv from vertex u to vertex v, u comes before v in the ordering. For instance, the vertices of the graph may represent the tasks to be performed, and the edges may represent constraints that one task must be performed before another, right? So I guess that's a bit more than we really needed to read. So we'll be doing this question called course schedule, which is a really good representation of top sort because it's just like it's also really probably like relatable too, right? Like in order to take, let's just say, X class at whatever school you're at. Okay, maybe not X, Y class. Maybe you need to take X class first, right? So like, um, this is just like a representation. This is like a code way of like, I guess, like checking to see if someone can do this or not, stuff like that. So what we'll be doing here is, I guess, trying to see if we can find if we can take all of the courses in this problem. Well, I guess I kind of skipped to the end because that's what we're trying. I didn't even read the problem yet, but there are a total of num courses that you have to take labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites I is equal to A sub I, B sub I, indicates that you must take the course B sub I first if you want to take course A sub I. For example, if the pair 0, 1 indicates you have to take course in that to take course 0, you have to first take course 1. Return true if you can finish all courses, otherwise return false. So we'll be doing this question, and so let's get into it. Right, so if the length of prerequisites is equal to 0, we can just return true. Because if there are no prerequisites, we can take them in literally any order. And so we can just break out of that there. Or not break out of it, but just we don't have to do anything there. Right, and then so we're going to create, oh actually, I need it, from collections import dq, because we'll be using it later. We're going to be calling this in degrees, which is a dictionary of I mapped to 0 for I in range of num courses. And then we're also going to have another map called out degrees I for an empty list for I in range of num courses. Oh, I didn't even put the first thing here. Whoops, my bad. So this is how we're going to represent like our courses, whether or not we can take them or not, right? So basically we're going to create two maps. In degrees is basically in order to take this class, we want 0 in degrees, right? So every time we find a prerequisite, before we can take this class, we'll increment this by 1, and the out degrees is after I take this class, what classes will I lower the prerequisites for? Well, not essentially lower the prerequisites, but it's like if I took this class, then I would have fulfilled the prerequisites, or like started to fulfill and perhaps completely fulfilled the prerequisites for taking said class, right? And so that's how we're going. That's what we're doing to represent this. So for I'm just gonna call it. So for this, you have to take this before you can take this, right? So I'm gonna call this P and C in prerequisites. The word always looks so weird. I always don't know if I typed it right. Oh, in order to take course 0, you have to, so it's C comma P. Sorry. So basically, for in degrees of C, you'll plus equals 1 because in order to take this class, you have to take one prerequisite before it, right? So we're going to make this at least 1, like potentially more, right? And then, so that way, later when we try to fill our queue with what classes we can currently take, we're going to say that this class right now we can't take, right? And then for out degrees, for the prerequisite, you're going to dot append C. Because once you take class P, you will lower the in degree for class C by 1, right? And so you're going to create a queue, which is a DQ. right? And then for the course and degree in degrees dot items, if degree is equal to 0, then you do q dot append c, because that just means we have 0 degrees that we need to, or like 0 classes we have to take before this class C, so we can immediately take that class. And otherwise, if it's greater than 0, then we can't take the class, right? And so while length of q is greater than 0, what we're going to do is we're going to take the course is equal to, oh, sorry. Before we do that, I'm going to create a variable called taken, which is the number of courses we have taken, right? And so here, every time we append a course, that's going to be one course taken, because once we add it to the thing, we've taken the course, right? And so course is equal to a q dot pop left. Actually, no. I'm going to rearrange this a little bit. So instead of doing that, we're going to do taken is equal to 0 here. And then when we pop it off of the queue, we're going to say this is when we take the actual class. So that's, we're going to increment taken here, right? So after we've taken this course, we're going to do for C in out degrees course. So it's all of the courses that this class is a prerequisite of, right? We're going to do in degrees, what the heck? In degrees C minus equals 1. If in degrees, typing is impossible. In degrees C is equal to 0, then you do q dot append C again. And so that we'll see if we can take every course, and taken plus equals 1 will tell us how many courses we have taken. And now we just want to return taken is equal to number of courses, and see if we have taken the correct number of courses. And well, not taken the correct number, if we've taken like the number of courses that we need to take, right? And so boom, this just tells us that you can actually take all the classes that you are required to take. And with that being said, thanks for watching. See ya next time.